good morning, all of you. Let us
Good morning,
start.
madam.
Sir. Let me start, sir. Respected Professor S.S. Patnaik, Director of the Institute, Professor P.S. Pabla, Guest of Honor, Professor Mechanical Engineering Department, Professor A.B. Gupta, Dean Industrial Coordination, Consultancy and Extension Services, Professor Maitri Datta, Dean Academics, Research and Development, other senior professors and faculty members of this institute, all the faculty members of different technical institutions, research scholars, both PhD and PG from different institutions, our own students who had joined this program as participants. Ladies and gentlemen, good morning to all. I, Dr. Lenny Matthew, Professor and Head, Electrical Engineering Department, would like to take this opportunity on behalf of the National Institute of Technical Teachers Training in Chandigarh to welcome all of you who are present online to this AICT QIP sponsored program on distributed generation and microgrid conducted by the Electrical Engineering Department of this institute. This is a 6 days program from today till Saturday, 14th August. The quality improvement program, which is being implemented and monitored by AICT, was launched by the Government of India in the year 1970. One of the main objectives of the program is to upgrade the expertise and capabilities of the faculty members of the technical institutions in the country. There are three main activities under QIP serving the faculty of engineering, degree level engineering, pharmacy and polytechnic institutions, providing opportunities to faculty members of the technical institutions to improve their qualification by offering admissions to master's and PhD degree programs, organizing short-term courses at the different QIP centers for serving teachers, and curriculum developmental activities which help to improve classroom teaching and learning. Out of all the QIP centers, our institute is also one of them. This year, our institute is awarded 10 short-term courses from AICT to be conducted online, and this is the second in the line. As the coordinator of the program, let me give you an introduction of the course. Conventional power stations, such as coal-fired, gas and nuclear power plants, as well as hydroelectric dams and large-scale solar power stations are centralized and often require electric energy to be transmitted over long distances. By the start of the 21st century, central plants could arguably no longer deliver competitively cheap and reliable electricity to more remote customers through the grid. So distributed generation or distributed typically use renewable energy sources, including solar power, wind power, small hydro, biomass, biogas, and geothermal power, and increasingly play an important role for the electric power distribution system. Distributed generation and storage enables the collection of energy from many sources and may lower environmental impacts and improve the security of supply. For reasons of reliability, distributed generation resources would have to be interconnected to the same transmission grid as central stations. Various technical and economic issues occur in the integration of these resources into the grid. Technical problems arise in the areas of power quality, voltage stability, harmonics, reliability, protection, and control. Lots of research is going on in this area in these days. Thus, we plan to conduct a research-oriented program by inviting eminent researchers in and out of the country and give exposure to the teaching community and young researchers the new avenues in which this emerging area is progressing. An arena of eminent professors, researchers, and industrialists will be engaging the sessions during this program. The course will cover areas like large-scale grid integration of renewable energy sources, protection issues with DG integration into grid, power quality improvement in solar integrated system, power quality and electromagnetic compatibility with energy efficient sources and loads, decentralized control of microgrid, islanding detection techniques on microgrid, wind electric generation technologies for the future, bladeless turbines for wind power extraction, solar powered electric vehicle charging schemes, fuel cell hybrid electric vehicles in urban transportation, various converters and controller topologies, distributed cybersecurity techniques for smart grid, and hardware and loop simulation of distributed generation sources and microgrid. I hope this program will be very useful for all the participants. There are almost 230 applications, and I hope a good number of you will be able to reap the advantages of interacting with eminent researchers in this emerging area. Without further ado, I would like to continue with our program. I consider a privilege, sir, let me call upon you or Pabla, sir, for the address. So I call upon Professor Pabla, Professor Mechanical Engineering, for the guest as the guest of honor for his address.
Thank you, Dr. Lenny Matthew.
Dr. S.S. Patnaik, Director of the Institute, Dr. Lenny Matthew, Head Electrical Engineering Department and Coordinator of the program, Dr. Maitri Datta, all my faculty colleagues from NITR Chandigarh who have joined online, and of course all the faculty delegates who have joined the meeting online, this course online. A very good morning to all of you, and I welcome you all to this program. This is not a 5 days program, this is a 6 days program because this is under QIP plan. NITR, as you know, we conduct a large number of programs on our own. In addition, we approach different agencies under different schemes to, for financial assistance as well as for sponsorship, for connecting programs in the new areas, upcoming areas, and multidisciplinary areas. So this program, which is being coordinated by Dr. Lenny on distributed generation and microgrids, is a part of the QIP initiative of AICT, which we have been allotted. Electricity, we are dependent on electricity, so we cannot do without it. And the generation capacity is also limited, but at the same time, the losses in the generation and transmission are huge. So I think we need to work on this. Few years back, Punjab State got the best electricity department award with minimum losses, but the losses were 20% plus. So I was just thinking that if the losses 20% plus we can get an award, I think there's a need to be very seriously thinking on reducing the losses and managing the system. So Dr. Lenny, of course with the guidance of Dr. Patnaik, has arranged a good number of experts who are experts, specialists in their own field. I'm very sure that they will address to all the issues concerned with the distribution and microgrids, and you all will benefit from this program. My only advice to all the participants is, please be serious, attend all the sessions, and ask any number of questions, so that you also feel involved, and the expert who is giving the lecture, he also feels involved, and he can give, because otherwise the expert presumes many things that they may be knowing, but as a listener, as a participant, I may not be knowing some things. So I need to ask. Since they are very good experts, they are specialists in their own areas, please do ask any questions, even if you feel that people may laugh on it. People will not laugh on it. Many of us will not be knowing what you are asking actually. So once again, I welcome you all to this 6 days program, and I'm very hopeful that you will have many takeaways from this program. The program will be very informative for all of you and help you in developing your self in a professional as well as in your career. So once again, I welcome you all and wish you all the best. Thank you.
Now let me welcome our director, Dr. S.S. Patnaik, who is a true leader, visionary, and having excellent persuasion abilities. Professor Patnaik joined this institute as director in August 2017. Before that, he served as Vice Chancellor of Biju Patnaik University of Technology, Odisha. He is a known researcher in this field of antenna and soft computing and has published 272 papers in journals and conferences. Under his charismatic leadership, this institute has reached newer heights in the past years. I call upon Dr. Patnaik for the inaugural address. Sir.
Thank you, Professor Lenny. Namaskar and good morning to all of you. At the outset, I must congratulate and thank Professor Lenny and her team for arranging so many good experts from IIT system. When I see the list, they could manage the consent from Professor Bhim Singh, unparalleled experts in the area of electrical engineering, Professor Paningrai, Professor Subdeep from IIT Goa, you name. So all these 17, 18 experts are from IIT system. In fact, this was the basic approach which you took a stand when the QIP AICT sponsored FDP was granted to us, that we thought that the support which we are getting from AICT must be utilized in a multiplier way so that we can draw good expert from the IIT systems, and the participants are given an exposure directly from those researchers who are working in their respective areas. So here the request to the experts are, they will talk only the areas where they are pursuing their research, they are guiding their research, and they are offering consultancy based on their expertise, so that the participants who are aspirant for PhD degree or who are already pursuing their PhD degree or already they are doctorate but they are looking for a better research environment gets exposed to these areas, get connected to these areas, get to know who are the people who are working in the national scenario in these areas, and through them get a strong network to pursue their quality research. So in this contest, these departments, my faculty members, they are almost all taking a lot of pain, contacting various experts. As you know, getting IIT professors from various IITs is not an easy task. It requires a lot of homework, persuasion, personal correspondence. After that only we get a consent from them. But today, at least the electrical engineering, prior to that also mechanical engineering, they did that. Electrical engineering also, they have done that. Even the 23rd QIP program, also you'll see that a lot of IITians are involved. Interestingly, they have also included some industry experts here. So that shows a blending of the latest research and how these research are getting practiced in the industrial scenario, because the industries who are going to interact with you, they are also doing some advanced research activities. So therefore, there is a very sincere approach by the department, give the best out of the best, and it is expected that as participants, you must reap the maximum benefit out of these efforts which the NITR Chandigarh is doing for you. So that this becomes an encouragement for my faculty member to see further that how further extension of support can be provided to you, so that you become a quality researcher to address the strategic issues and some industrial issues of these countries. So in this contest, like this department in past also through their ARPIT program, they have already gained a name for themselves in national competition scenario. They have delivered well, though the faculty members are young, but they have a different type of exposure, sincerity, and they've really created a different type of history for this department. Under the leadership of very sincere, aggressive HOD, Professor Lini, the department is really going to a different height. I'm seeing they're now traveling in a different orbit altogether. The department which I had seen in 2004 was in a different orbit. Now they have propelled themselves to a different orbit, and their orbit is now is too dynamic, very well there, placing them in the higher orbit. And that, so they deserve, in fact, a congratulations from all of us, all our colleagues, including me. They deserve that congratulations. The department also has Center of Excellence in HIF. So it is not that only the expertise they are arranging, they are also taking care of the facilities which will be extended to you. Even they have contacted the companies where it is possible, they are going for the web labs. So they are trying to see that a web labs is also established so that the remote participants get advantage of the facilities which are available to them. So the department is quite broad in the sense, broad-minded. They want everybody to get exposed to the facilities. So the facilities are for you. Only thing is that how much you are taking extra care to take advantage of these type of things which are happening in this electrical engineering department of this institute. So with this word, I once again wish that all the participants will, in this 6 days time, will get a lot of academic learnings. They'll get a clear direction to pursue their quality research. They will also get an advantage of this type of participation to create that networks, because in this scenario, unless you are network with good institute, good experts, cannot do really good research. So collaboration is another way of exploring in this type of platform. So hopefully this platform will give all that what you are looking forward to. So God bless all of you. Thank you so much.
Thank you, sir. Thank you, sir, for your good words. At the end, I would like to call upon Dr. Shimi SL, Assistant Professor, Department of Electrical Engineering, to propose the formal vote of thanks. I request all the participants to remain online after this, and we will continue with the first session on large-scale grid integration of renewable energy sources by Dr. Bharat Singh Rajpurohit, Associate Professor, IIT Mandi. I think he's already connected. I welcome you, Dr. Purohit. Over to Dr. Shimi SL for the vote.
Thank you, ma'am. It gives me immense pleasure to deliver the vote of thanks for the AST-sponsored STC on distributed generation and microgrid. First and foremost, I would like to thank our worthy director, Professor S.S. Patnaik, who had been a source of inspiration for all our programs. He always motivates us to take up new topics or new topics in our area, and he always helps us to bring new experts also. So thank you, sir, for all your motivation. And next, I would like to thank our guest of honor, Professor B.S. Pabla, then our Dean Academics, Professor Maitri Datta, Professor A.B. Gupta, who is Dean Industrial Coordination, Consultancy and Extension Service, for all the support they have extended us. I would like to thank all the participants without whom this program wouldn't have been materialized. I would like to thank all our experts who have accepted our invitation in spite of their busy schedule. Last but not the least, I would like to thank all the departments of NITR who have supported us, mainly the IMEE, then the Science Department, Estate Department, and all other departments who have helped us to conduct this program in a smooth manner. Thank you.
Dr. Bharat Singh Rajpurohit is here with us. Sir, welcome.
Hello, good morning to all. Thank you very much, madam. I'm here. Yes.
Yes, sir.
So, good morning to all. It seems to me that this is the first session. So, as we understood that this is a new game that we are interacting all of us over virtually and mostly just by having this video conferencing system. So it would be good that you please take time in just asking me or any other in coming time, any other experts also, so that we will be able to have more interaction here, so that the interaction here is fruitful to all of us. And if someone is raising a query, then it helps others also. So please feel free in that. Meanwhile, if you would like to write, you may write in the chat box also, so that I will be able to stop at some point of time and will be able to do the questions. So please feel free in that direction. So my expertise is in the area of large-scale grid integration of renewable energy. So today I will be interacting with all of you about the what are the technical challenges are there, and if the time permits, we'll be able to see what the economic issues are also there. Before going to further into detail, I would like to just brief where the IIT Mandi is. IIT Mandi is considered as more like a second generation of IIT, started almost 10 years ago. We are in a city known as Mandi, which is in Himachal Pradesh and which is almost 450 kilometers from Delhi, and we are in the Himalayas. So we are able to see you can say snow peak from our campus. So it is a very beautiful campus, and I invite you also on behalf of Institute, if you find time in coming few months when the situations are better, you please take opportunity to visit us. This is just a picture which is 6-7 years old when we have started. It is like two part of campus is there and separated by a very small mountain. Very lush green campus is there now, which is being developed. We are having broadly 4 schools: School of Engineering, School of Computing and Electrical Engineering, School of Basic Sciences, and School of Humanity and Social Sciences. And by having school and very limited number of school, we are trying to develop a interdisciplinary working culture, and which we are able to see we have developed. In addition, we are also having few research centers, especially related to the bio and the advanced material in that sense. And in the Center for Design and Fabrication, we have developed a very excellent facility of clean room of class 100, and with a very, you can say, highly sophisticated instrument for the device fabrication. In other than that, we are also working on civil area. We are also working on renewable energy in an institute with a good focus. Broadly, my school, the School of Computing and Electrical Engineering, offers a degree in electrical engineering. We are also offer a degree in computer science, MTech programming, VLSI, power electronics, communication, computer science, like that. And recently, we have started a BTech degree in data science also. And other than that, we are also offering a degree in MS by research and PhD also. MS by research is a 3 years degree with a PhD is having a like longer duration of around like 4 to 5 years. These are some of the pictures what now our campus is standing today. These are some of the hostels, residential and academic buildings. Some of the academic buildings are still in development. You can see it in the right hand side. Some of the glimpse of the campus inside of that. It's something developed like a very big village in mountains, so that feeling is coming up. So now coming to this topic, that large scale grid integration, we are able to see that our focus is on to have a sustainability in the electrical power supply, as well as then we are, as a country, we are thinking that we should have a security of supply also. So when we are considering this, we are able to see that there are a couple of solutions are available to us, which is one of the important solution is that to transition to a renewable energy. And if we are talking about renewable energy, suddenly we are able to see there are two major sources which we are able to see is able to provide a large source of generation of electricity and which will be able to replace our conventional sources, which is predominantly is dependent on the large synchronous machines. So wind and solar, which are able to develop as a wind farm and solar farm, will be able to replace a conventional thermal power station, just and for an example. And when we are talking about wind and solar power, we are able to see that technology is matured enough and they are able to develop very fast as compared to the other sources, conventional sources. So once a land is allocated, the development of wind and solar farm is like in matter of months as compared to the conventional sources. And we are also able to see when that thousands of solar panels, thousands of wind turbines, when they are combining together, they will be able to have a big generation source to have a very large contribution to the sources. The government of India has given a very good focus since many decades to promote the renewable energy, and we are having a complete ministry is given known as Ministry of New and Renewable Energy to promote the renewable energy. The broadly renewable energy is divided into like grid connected, captive or distributed or off-grid systems where sometimes we are using electrical power, sometimes we are using direct solar energy or other means of energy for our day-to-day purposes. Mostly we will be interacting to have a grid connected electrical power utilization of the renewable energy. And other than that, we are also able to see there are many schemes, regulations were also given and formulated by the government of India by different ministries to promote the renewable energy, whether it is a grid integration, whether it is a providing a subsidy, whether providing a new policies, and especially like an open access, which came in 2003 to promote the renewable energy at a very, very basic level. So this is how we are able to see. Today, we are able to see that that a penetration level of renewable energy has increased a lot, and slowly that it is also producing a good amount of energy also. And in the renewable energy sector, wind and solar in our country is almost going equally, and they are able to have a very good installed capacity in certain pockets of country, and other part of the country as the resources are available, slowly it is also extending in that direction. Solar has taken a very strong growth in last few years, especially when the Jawaharlal Nehru Solar Mission has launched by the country, and it is coming out very, very nicely. In addition to that, we are also having very specialized centers to promote renewable energy, whether it's to provide a technical inputs, to provide a policy, to provide a certification, to provide a validation of the technology, like Center for Wind Energy Technology, now known as NISM Institutes in Chennai for the wind, then Solar Energy Center in Gurgaon, AHEC at Roorkee. So these efforts are already there. Now let's go into more details. That while still renewable energy is the penetration level should be high, but still why it is not there, and what are the other forces which is helping to promote the renewable energy. The one of the regulation which we are able to see came many years ago, and slowly it is able to put a stricter role to have a more renewable energy utilization by the states is known as RPO, or known as Renewable Purchase Obligation. What is this? The RPO is known as minimum amount of renewable energy to be purchased by the state in order to meet the mandatory electrical energy requirement in that particular state or by distribution companies. But who is going to decide what is the mandatory electrical energy requirement of that state? That is done by the State Electricity Regulatory Commission, known as SERC, of the respective states. So it means respective states, based on the state location, based on the state geographical condition and other factors, are prescribing that certain amount of energy should be consumed by the renewable energy. For example, some of the states maybe say that 10%, some of the states may give lower, some of the states may give higher. And this is known as obligation. It means this is need to be followed and need to be obligated by the power utilities. It means some penal or penalties can also be levied if it is not met. So this type of system, the regulation will be able to force the power utilities to have the renewable energy. Now you will be able to see that it is saying that to be purchased by the state. So whether it is being actually consumed or not, no one is demanding that, but it is to be purchased by the state. It means state is investing in having a renewable energy, whether they are utilizing or not. This particular sentence is also give a hint that there is one economic mechanism is there to promote the renewable energy, generally known as renewable energy certificate or REC mechanism, in which to help the states, especially there where the geographical conditions are not such that where the renewable energy is not available. So in nutshell, we can see that renewable purchase obligation is one of the regulation which will be able to make sure that each state is investing, each state is promoting a certain amount of renewable energy in respective state, and the targets are given by the regulatory commissions, and this target is eventually are coming from the very bigger targets like National Action Plan on Climate Change, what the government of India is committing to at the world level. So this is how we are deciding on. Any query or concern you would like to ask, please let me know.
Yes, sir. Can I ask one question?
Yes, please.
Yeah, sir, regarding this RPO, renewable purchase obligation, so state has to purchase through center, sir, or what is the purchase mechanism?
Okay,
Center
there are
provide, yeah.
Yes, you are right. That how let example, we are having a distribution company in a particular distribution area from where they are buying the power. They will be going to have a state generation. Like in Himachal Pradesh, there are a few hydropower plants are there which are state owned. They are producing, and the distribution companies are getting the power from that. Still they are not able to meet that power. What they will be able to do, they will be able to request then their share in the state ISGS, generally known as interstate generation capacities, where their shares are there, in which like in BBMB, Bhakra Byas Management Board, in such schemes where their share is there, they will be able to get their share. Still, if they are not able to meet their requirement, they will be able to have a bilateral contract with any thermal power station or any power generation which are able to provide. Then finally, the next point is that they will be able to buy the power from the market exchange. We are having two market exchange known as power exchanges, where they will be able to buy the power. So there are many options are there. Now let's coming to the renewable energy. So renewable energy plants are sometimes like state-owned, sometimes they are also developed by the private players. So the state companies can have a bilateral contract with such type of players, and then they will be able to buy the renewable energy. Fine. So this is how the mechanism is there, and then one more mechanism is there that power grid, what our grid is there. From there also certain amount of power can be extracted, and the money is being exchanged for that power is linked to the frequency and known as unscheduled interchange mechanism. So there are very good number of possibilities are there by where a distribution company can buy a power, and in the terms of renewable energy, bilateral contracts are very easy and straightforward, by which the distribution company can buy a power. Now, what amount to be paid for this bilateral contract? It depends on the negotiation. Then second option is that State Electricity Regulatory Commission is giving a preferential tariff mechanism, in which based on the state condition, a preferential tariff is given for the each renewable energy source. So the state utility can pay that preferential tariff and will be able to take the power. Other than that, finally there is a mechanism known as renewable energy certificate mechanism, in which state can just buy the certificate in a market exchange, but there is no need to buy the actual power. So, and then they will be able to utilize these certificate to claim the RPO obligation. So there are many ways are there. We will be going to discuss especially the REC certificate if the time permits towards that. Okay. Is this fine?
Okay, sir. Thank you, sir. One more thing, sir.
Yes.
If some state can generate renewable energy in a sufficient amount, so will there be any obligation then also? Then it has to purchase if it is having sufficient generation capacity of renewable energy. Yeah.
Yes, I think so. State Electricity Regulatory Commission will then force them to buy a certain amount of renewable energy either through a bilateral contract, and now open access mechanism is there. They will be able to have a bilateral contract. Let Karnataka may have a bilateral contract with any wind farm owner in Rajasthan or Gujarat also, or in Tamil Nadu also. So open access allows that, but it will be a bit more costly as the distance is there due to the billing charges. But it is definitely possible, and which my understanding, state electricity regulatory commissions are giving a targets based on the higher targets what the government of India has committed. Fine.
Okay. Thank you, sir.
Okay. Any other query?
Excuse me, sir.
Yes.
Sir, how that private company, they have the renewable energy park, how they oblige this RPO?
Which private company? Can you please just repeat?
Just like Adani, some Ambani, they have they are on invested in the renewable energy sector, and they have their own plant.
So now I got. So what you are saying is more about the power generation sources. Like if someone is having a thermal power station like Adani is having. So I am talking about distribution companies who are providing a power to the customers. Fine, generally known as DISCOs. So the RPO requirements on those type of distribution company, not on the generation companies. Fine. So if in example, if we are having a company known as Tata, which is having some part of distribution area. So they have to make sure that they are buying a sufficient amount of renewable energy from the renewable energy sources to meet their RPO requirements. So this is more on the distribution company, which they are actually utilizing the energy or selling the energy. So this requirement is for the distribution companies.
Okay. So what is the minimum limit, sir, for 10%, 5%?
Yeah, it depends on state to state. Each state is having different range. Sorry, different limits. Okay.
Okay, thank you, sir.
So now we were discussing that with increased penetration of wind and solar power, then the responsibility of maintaining a stability or the reliability of the grid is also now slowly changing. So earlier, the conventional power plants, which are made up of a very large synchronous machine, which is now slowly getting replaced by thousands of small generators, whether it is a wind or thousands of small power electronic converter interfaced system. So slowly we are able to see that control aspects is changing, making the primary and secondary control for the power grid is also changing. So earlier, what was the system? When the penetration was low, during any abnormal condition, the renewable energy systems were simply getting disconnected to safeguard them for it, like due to very high current. But now it is not expected because the penetration level of wind and solar is very high. So if they have already replaced a large synchronous machine, then, or if it is going to do in future, then it is not possible or not tolerable that simply they are getting disconnected during abnormal condition. So this is how we are expecting that wind and solar or other renewable energy sources should meet minimum grid connection requirements, or known as grid codes, to make sure that primary and secondary control or the grid stability can be maintained. So this is now is expected. Other issues with the renewable energy is that there is a intermittency is there, which can be addressed by having a proper scheduling mechanism and having a forecasting techniques. And initial high cost, which is slowly is getting lower and lower by having different mechanisms also in country we are able to see. So broadly, we are able to see there are two topics that need to be understood with a large scale renewable energy integration. Is one is the grid connection issue, another one is the economic issue, that which is overall can and give us a hint that this is a system operational aspects that we need to understand. Fine. So what are the grid connection issues? Now we are slowly going into more technical part. Please feel free to stop me whenever you would like to have more discussion. That what is the grid connection issue? The grid connection issue is expected that whenever a new source or new load is getting connected to the power grid, they should also be having a certain responsibilities. They should be following a certain mechanism. They should be following a certain codes, so that the system is getting maintained with a proper stability and the reliability. So grid codes are known as the technical guidelines and requirements for the renewable energy sources, which need to be followed. Fine. So this is what is known as grid codes. Broadly, the grid codes are divided into three categories. One is known as active power control to maintain a frequency regulation. Second one is reactive power control for a voltage control. And third one is fault right through capability. So then smaller issues are also there, that how to do a scheduling, dispatch and forecasting to address the grid connection or grid codes. Then smaller issues are also there, that when a renewable energy sources are getting developed very fast pace in some remote area, but there is no power evacuation mechanism is available by having a existing power transmission line. So it means a power transmission line also need to be laid down, and which power grid is having a very strong working on that, as well as having strong vision generally known as green corridor, to evacuate the renewable energy power from certain pockets where the existing power lines are not available. So such issues are also continuously being taken by the different power utilities. But broadly, we'll be going to discuss what is the active power control, reactive power control, and fault right through capability by taking in a certain example, that how these control can be exercised, can be met by the renewable energy with an example of wind turbine. We will be able to see how a wind turbine will be able to meet such grid codes. Fine. So slowly we will be able to see. So, but what is a wind turbine or what is a wind power? Wind power is a power which is available in a moving wind and which can be extracted by this kinetic energy can be extracted by having a turbine from kinetic energy to mechanical energy, and then a electrical generator which will be able to convert this electrical energy, mechanical energy into electrical energy, and then by having suitable powertronic converter or mechanism, this electricity which is being generated can be specified within a specified voltage range and specified frequency range, and which will be able to meet the required specification of the power grid. So this is how the overall scheme is working. And how much power is available? Power is available as half rho A V cube, where rho is the density of the moving fluid, A in this case, A is the rotor blade swept area, and V, capital V, is the velocity of the wind. So that's why we are able to see with a longer blades the rotor swept area is increasing, so it means power from the wind is increasing. But here V cube is giving us a very good indication that wherever the higher wind velocity is there, power is getting higher due to V cube relation. So it means better windy sides are required to get a more and more power. This slide is giving us some detail that wherever the higher wind potential is there, this data is being old. Now with a higher hub height of wind turbines, and many new locations are also being identified, and this capacity is coming out something like more than 90 gigawatt. So this, I think, we have already discussed. Now coming to this wind energy conversion scheme. So this is giving us a detail that what are the different type of wind turbines and wind energy conversion schemes are there on different type of generators scheme, different type of gearboxes mechanism and other partonic system. So what is a basic scheme? The basic scheme is having a wind turbine, generally 3-blade system. Then gearbox, which is optional in some of the system. Why the gearbox is required? The gearbox is required to meet the speed requirement of an electrical generator. Electrical generators are designed for a higher rotational speed to maintain their optimal weight also as per the flux requirement, and generally it is like 1500 rpm, 1800 rpm and like that. But the wind turbine, the 3-blade mechanism or 2-blade mechanism, they are rotating at a speed of like 15 rpm or 12 to 18 rpm. So these are the slow moving you can say schemes. The reason for that is that their design optimally is based on this lower speed, and to meet this speed requirement, a gearbox is there. Fine. Then partonic converters are there, as I mentioned earlier, that partonic converters are available to make sure that whatever the power is being generated by the generator is having the can be feed into the grid with a proper voltage and frequency, and so that's why power converters are also available. In some scheme they may not be required, but in most of the scheme it is required. Then power transformer to meet the voltage level like that. So this is what the overall scheme is there. Let's see couple of basic schemes. The first of the basic scheme, which is mostly developed and deployed in India from many decades. This is the most robust scheme based on squirrel cage induction generator. The squirrel cage induction generator, you must be aware of, it is a generator which is based on induction machine, and where the rotor is a short circuited rotor, and due to the construction this is known as squirrel cage induction machine. So this generator is directly connected to a wind turbine, and it is able to generate a power through a capacitor bank is provided, because the renewable energy based on induction machine is not able to generate the reactive power. But for the operation of the induction machine, a reactive power is required. So this capacitor bank is able to provide a reactive power locally. So it means it is not taking the reactive power from the grid. So that's why this scheme is having certain limitation, that reactive power is not able to generate, but it requires the reactive power, and it is being supplied by locally by a capacitor bank. Fine. But as the new grid code, we will be going to discuss that reactive power supply is also required from the renewable energy. So such type of scheme may not be good to meet the grid code. So this is one of the input we are able to see. Otherwise, this scheme is very popular, very robust, very economic, and has you can say having long life with a very good connections to the grid. So this is known as fixed speed system because it is operating in a very narrow band of speed range, and it is not having a wider speed range. So that's why known as fixed speed. But we are slowly able to see that new wind turbines which are coming is based on variable speed system, and generally they have used some of the mechanisms by which a speed can be varied either by using partonic converter or by some alternate mechanism. The literature is saying that by having a variable speed system in which generator speed can be varied in a broader range, the energy which is coming out from the moving wind or varying wind is higher. Some of the data is saying that based on some site it is 9% higher as compared to fixed speed system, and somewhere it is even going up to 40%. So in a nutshell, the meaning of fixed speed and variable speed system, the differentiation here is that by utilizing a variable speed systems, the energy from the same wind can be captured more. It means energy output of that wind farm would be higher if it is using a wind speed system, which is a variable. Any query in this case, then please let me know. Any query in this case, then please let me know.
Sir, would you elaborate DFIG?
Yes, we will be going to discuss DFIG in more detail just in few slides.
Okay.
Now, just see that first schematic, the first one, the topmost left-hand side. This is known as wound rotor induction generator, where rotor is having a variable resistance. This rotor is a other than what a squirrel cage induction machine rotor is there. In this case, rotor is having a winding, and this winding is being terminated by having a resistance, and this resistance can be varied, and this scheme can be utilized to vary the speed of a wound rotor induction generator. By this, the system can be made at a variable speed. Now the middle scheme is going to have the same scheme for a squirrel cage induction generator, synchronous generator, permanent magnet synchronous generator, where the stator is connected to a power electronic equipment. There could be different type of configurations are possible, but ultimately the AC is being generated by the stator. This AC is of a different frequency and different voltage level. This is converted from a AC of different voltage and different frequency to the AC alternating current of the desired level and desired frequency, which is as per the grid connection. So this AC to AC converters are able to process the electrical power so that this power can be fed into the grid. And by controlling this powertronic converter, the generator system, the wind turbine system can be have a variable speed system. Fine. So this is also a scheme. Now please see the bottom left hand side figure, which is known as doubly fed induction generator. In this case, the name is doubly fed because the generator is connected through a stator as well as through a rotor. So it means it can be fed from double side. That's why the name is doubly fed. So this doubly fed induction generator is having a rotor which is connected with a powertronic equipment. So the bigger advantage between the middle and the bottom scheme is the powertronic equipment which are connected in the stator or the middle scheme is having a same rating of the generators, but in the rotor DFIG scheme, the powertronic equipment are connected in the rotor where the power processing is low, and hence the rating of this powertronic equipments are low. So this is why we are able to see the overall DFIG scheme becomes more economic as compared to the middle scheme. And there are certain control flexibilities are also available, and by this scheme becomes the most popular scheme worldwide, and it is able to give a better power quality and reduce cost, and it becomes a very convenient, and many companies are making such type of wind energy conversion scheme. By controlling the rotor side powertronic equipment, once again DFIG can also be controlled, and hence we will be able to see that this becomes a variable speed system. Fine. We will be going to discuss DFIG furthermore because we will be going to see how the DFIG can be controlled to meet the grid code. Fine. Now, before moving, let's understand how the variables.
Hello.
Hello.
Rohit, there are two raised hands. Mohan Bukia, you can ask.
Yes, ma'am.
Yes.
Yes, ma'am. Sir, Bharat sir. So,
Yes.
Nowadays in wind energy systems, two missions are there, sir. DFIG as well as permanent magnet synchronous generator.
Yes.
Among the two, which one is the best?
Okay, so this is a very good question, and it is very difficult to answer also. As I was mentioning, there are two aspects are there, and which is what an engineer is always struggling. The first aspect is about the cost. So when we are as an engineer, when we always see that which is the most economic scheme and whether it is able to achieve the objective. So in that case, DFIG is topmost. DFIG is able to inject a power. It is a variable speed system. The cost is also less. It is able to work very fine. That's why I'm saying it is most popular scheme. Even some of the data is saying that the 45% of the wind, you can say, wind energy conversion which is getting installed is based on the DFIG worldwide, and all other schemes are remaining 55%. Fine. But few of the recent studies are also showing, when we are talking about fault right through capability, it means when a penetration level of wind is very high in a certain country like Germany or Denmark or even in India also, and a fault is happening, so to bear that fault and to remain connected to the grid and once again start giving the power to the grid, that capability is high in a synchronous generator as compared to the DFIG. So that capability is giving us a hint that once a very high penetration is there, the synchronous machine, synchronous generator scheme are better as compared to the DFIG when a very high penetration level is there. So now it is dependent on the what is philosophy. If the philosophy is the economics, DFIG is performing better, and if the philosophy is to have a better stability, synchronous machines are better. Now coming to the permanent magnet synchronous generator, the cost of the PMSG is higher as compared to the DFIG because they are using a permanent magnet. Then otherwise they are also very fine. They don't want any reactive power supply from outside, and they will be able to provide the reactive power also. So when we are talking about synchronous machine, PMSG or DFIG, the major role is now coming either economics or the grid stability. So there is a trade-off. Some of the companies are making, like Repower are making PMSG, GE, Suzlon, they are working on the DFIG. So this is just like a that which company is working and how they are able to get a more contract. This is how they are operational. But research point of view, synchronous machines are giving a better stability performance as compared to the DFIG. I hope
in PMSG we can avoid a gearbox also, no, sir?
Yes, in PMSG gearbox is optional. You are right. By having more number of poles in the stator, the speed can be controlled by such a way that gearbox can be made optional. That is then advantage of PMSG. Yes, you are right.
Thank you, sir. Thank you. Thank you.
Okay.
Okay, Mr. Mohan, can you please mute? Mr. Mohan, please mute.
Yes, ma'am.
Yes, Mr. Saravanan, you also raised a hand. Sorry for interrupting, Professor Rohit.
No, it's okay. We are here to for these discussions.
Okay,
Yes.
I think he is not reacting. Okay.
Okay. Any other query? Please feel free to raise now.
Mr. Saravanan, you raised your hands in between.
Madam, by mistake, the raise hand button is pressed, ma'am.
It's
Nothing
okay.
is
It's
okay.
okay. It's okay. Okay, Professor Rohit, you can continue.
Okay. Is there any other query? Then please feel free. Because I am not. Yes,
Yeah.
go ahead.
Yeah, sir, out of these three schemes which you have shown in this slide, which is more efficient in terms of energy production, renewable energy production?
I believe that DFIG is having the better economy as well as the better efficiency.
Okay, sir.
The reason is the power electronic equipment which are established in the stator side, they are having a processing a higher power. So that's why their losses in the power electronic equipments are also high. But as the rotor power electronic converters are established in the DFIG, they are having lesser losses. So overall losses would be low in the DFIG. So that's why it is having better energy efficient. Not energy efficient, better efficiency should be there.
Right, sir. Thank you.
Okay, good. So let's see why a variable speed system is able to generate more power. Fine. So for that, please see that a expression that power from a wind turbine rotor. This is now a mechanical system, wind turbine rotor, 3-blade system, is having a power coming out as a CP half rho A B cube, where A is the rotor swept area, rho is the density of air, V is the velocity of the wind, which is B cube. CP is what? CP is the known as power coefficient, and this CP is based on theoretically a limit is there known as Betts limit. If you are able to search that how to find out this Betts limit, it is a very nice derivation, very small derivation is there, which is based on every fluid which is moving, and the conversion is controlled by that. So this limit is saying that the maximum energy which is available as a kinetic energy, out of this, the only around 59% can only be translated into, let's say, mechanical energy, not beyond that. So there is a theoretical limit. So why this theoretical limit is there, I request you to please go through that. Very simple understanding of BTech first year level. If you have gone through any hydraulics course, you may be remembering that. But right hand side top figure, you can say the CP coefficient in this curve, you can see is coming out somewhere 0.39. So this theoretical limit is 59%, but when you are actually designing a system, mechanical turbine, we are able to see that limit is coming somewhere like 40% or so like that. It means mechanically the actual system is even at the lower. So whatever energy is available, we are slowly not able to see that, we are not able to convert them into properly or completely into the mechanical energy. Fine. Now this power coefficient you can see is also varying, right hand side top figure. By which factor it is varying? The factor is power coefficient is varying with a tip speed ratio, TSR. What is this tip speed ratio? It is given in this slide. It is known as R omega by V omega, VW. What is this tip speed ratio? The tip speed ratio is a ratio of tip of the moving blade with the wind speed. So wind speed is changing. Tip speed of that moving blade is given as R omega, radius of the that blade, and the omega is the velocity of that moving turbine. So now we are able to see that power coefficient is going to be maximum for a certain tip speed ratio. Velocity of the wind is continuously changing. So it means we need to continuously change the omega so that we are always at the optimum tip speed ratio to have this CP coefficient maximum. I hope you are able to follow this. We need to continuously changing the speed of this moving wind turbine omega, which is generally 12 to 18 RPM, 12 to 18 RPM for that moving 3 blades. By continuously changing this omega based on what is the wind velocity. Wind velocity is not in our control, it is changing. So by changing this omega based on the wind velocity, we can make it optimal tip speed ratio so that we are always working on the CP maximum. In the right hand side, you can see that tip speed ratio let 5.8 is there, then we are getting 0.39 as a maximum coefficient. This is a design based on the design of a mechanical wind turbine, the 3 blade system and the turbine system. So this is what coming from that. Is this okay? Any query in this? So now we are able to see we need to have a variable speed system so that we will be able to change the omega so that we are able to get a CP maximum point, and hence we will be able to extract the more amount of energy from the moving wind. Generally, this tip speed ratio for a fixed speed system is designed in a certain value, which is we are able to see is a like optimum, but when the variable wind is always there, that system is not so efficient as compared to the variable speed system. Now to understand this better, let's see right hand side below figure. What are this figure is on which relations are there? This figure is coming out between power of a generator, and the below side the speed is being translated to the generator side, which is like a generator side referred turbine speed. The speed is, you can see, is varying from that 500 to 3000 RPM. What are the different characteristics? These are the different characteristics are based on the different wind speed. So let topmost characteristics is 12 meter per second. 12 meter per second is a wind speed. For that we are able to get a generator characteristics. Then 11 meter per second of wind speed, 10 meter, 9 and 8 and like that. Now all these characteristics you are able to see that maximum point are at different generator speed. So 12 meter per second, the maximum point is somewhere is coming out at 1800 RPM. but for 11 meter per second wind speed, the slowly the wind, the maximum power is coming out somewhere at 1600 rpm and like that. So it means the generator characteristics is varying, and with a different speed of a wind, the maximum point is shifting in this case towards the left hand side. So if we want to always obtain a maximum power point, we need to use a algorithm known as maximum power point tracking algorithm, MPPT, sometimes known as MPPT. And how this MPPT is working? MPPT is working by always changing the speed of a generator system so that the maximum power point is being tracked. So this is just a fundamental principle for a MPPT technique, and this can be obtained by controlling the powertronic converter to vary the speed. How it is being implemented actually? This is being implemented actually in a scheme by storing a data in a lookup table, in a control system, in a lookup table where the maximum power point of a power versus the speed is being stored. And in this lookup table, the input signal is coming from what is a wind speed. As the wind speed is coming, we will be able to see that what is the maximum power and what is the corresponding variable speed should be there, and we are just giving that variable speed output to the control system. Okay, that whole system should go to that reference speed. So this is how being implemented actually in the variable speed system. Fine. So with this understanding, we can see that a variable speed system, we will be able to obtain CP maximum, so that we will be able to have a maximum power point. So such type of system is need to be implemented for a higher efficiency, and then we are able to see many grid codes are being given by different countries, including India also now, and especially the German grid code was one of the grid code which was leading the worldwide in technical sense, and slowly they are getting upgraded as the penetration level is changing. Now coming to the grid codes, let's see the first grid code, which is known as active power control. If you are having any doubt, whatever we have, or any query, any discussion you would like to raise, whatever we have covered till now, would you like to please raise? Okay, so let's see and continue for the active power control. So when we are discussing about the active power control, the meaning is that how we will be able to control the active power of a wind farm. We are taking an example of wind. So we will be able to control the wind farm output. As I just mentioned, we will be able to have a power reference set point, and that can be changed. And this control ability is that when a power reference set point is being changed, the powertronic system is changing the variable speed system so that the output can be controlled. In some cases, the output can be controlled by having a blade pitching mechanism. So by changing the angle of the blade on which the air is striking, once again a power can be controlled. But the power grid operators, transmission system operators, they are not bothered how the technology is changing the power. They are more bothered that we want to control the active power output from a wind turbine. So this is how the control is being exercised for a variable speed system or a fixed speed system. Now the next question is that if suddenly a wind is blowing in that area, so whether the output of a wind farm can also be increased suddenly with a step output. So that should not be there. So that's why a ramping control also need to be available, by which it can be seen that how fast a wind farm can be able to generate. So that ramping control limit is also provided. Fine. Then there is a fast down regulation. What is the meaning of fast down regulation? The meaning of fast down regulation is that when a wind farm is operating and suddenly due to a higher power generation available and frequencies going above, it is expected that the wind farm should reduce the power output, how fast they will be able to do. So this fast down regulation limit is also coming. I will give you a data for all these regulations, that what is actually is demanded by the grid in Indian condition. And finally, it is coming out a automatic frequency control. What is the meaning of automatic frequency control? The meaning of automatic frequency control is that as the frequency is varying in the Indian condition between a band, the power generation should also be able to change so that it is able to make sure that power is always such supply in such a sense that it is supporting the frequency to maintain at a nominal frequency of 50 Hertz. So in one sense, it is possible for a wind turbine because we will be able to reduce the output from a wind turbines, wind energy conversion system by controlling the power tonic system or blade pitching mechanism. But is it possible to increase the output from a wind turbine? Is it possible? Then we are able to see it is not possible. The reason, we are already working on a maximum power point tracking. It means whatever maximum power is available, we are always using or working on that point, and suddenly if a grid is asking that frequency is low, we need to increase the output from a wind energy conversion system, we are not able to increase because we are always working on maximum power point tracking to extract the maximum amount of energy. So it means participation in a lower frequency of a grid to increase the output for power from the wind turbine is not possible. Then what is the solution? Then many solutions are also provided by different researchers, sometimes being exercised also. The one of the possibility is that why to work on the maximum power point tracking. So is it possible for having a more stability in the grid or participation in the frequency control? Can we operate in a range of let a 10% reduced to a maximum power point tracking, so that this 10% amount of energy which we are continuously losing can be utilized whenever the frequency control is required. So this is one of the philosophy. Second philosophy is saying that whenever the moving rotors are there in the wind turbines, why not just to utilize their energy which is in inertia for momentarily to provide an extra amount of power. So these are the couple of philosophies are there. Some of the philosophy may be used for the participation in the automatic frequency control. Now you will be able to see that a curve is also given here, which is saying that once the frequency is going above 50.3, the power should be reduced in a certain rate, and if it is the system frequency is beyond 51.5, generation should be stopped completely by having a 0% of the power output from the wind turbine. So this curve should be followed by the wind turbine by appropriate technology. Fine. Now please see all this data what I was talking about. Let's see, the adjustable upper limit is there. It means 20 to 100% power can be changed. Ramping control is saying that the upward direction 10% of the rated power per minute, and similarly for the downward direction also. These are the rates are prescribed by the Indian electricity grid codes. Then fast down regulation is saying that 100% to 20% of the rated power should be within the 5 seconds. Then frequency control I have already mentioned. Fine. Then there are some governor controller are also prescribed, and then some of the more technical limits are also being given, which is available in the technical standards for connectivity of the grid in the 2019 amendment, where 10 megawatt and above wind farms are it is given. Fine, you may please refer that. So now coming to the reactive power control. So if you are having any query for the active power control, then please let me know.
Sir, can you quickly explain the previous slides, the data which you have provided?
Here?
Yes, sir.
So now you will be able to see that whenever the frequency deviation is there in excess of 0.3 Hertz, fine. So then generating station. So this generating station should not be only the conventional, it should be the with solar panels, SPV farms or wind farms are there. So they should be able to provide the frequency response as per the frequency response as the 10% of the maximum AC power. So this is what it is expecting. So when the deviation is beyond 0.3 Hertz, then it is possible, if it is like increasing the frequency, then it is possible to reduce the output from a wind turbine. So that is possible. The 10% output should be reduced for every 0.3 Hertz. So that is possible. But now the question here is that is it possible for the SPV or the wind turbine to increase the 10% of the output? So this is what an important question for the technology. So here, that's why I'm saying that suggestion here is that why not to always operate somewhere like 10% lower to the maximum power point tracking algorithm, whether it is SPV or whether it is a wind turbine, so that some margin is available which can be increased if the demand is there based on the frequency deviation. You know? So this is what is there. Then similarly, some of the other controlling limits are also prescribed here. You know? Okay. So now again coming back to the reactive power control. So here the philosophy for the reactive power control, what is expected from the renewable energy sources is that they should be able to operate with a zero reactive exchange with the grid. What is the meaning of that? The zero reactive exchange is that neither they are taking the reactive power, neither they are giving the reactive power to the grid. But in a broader sense, that net reactive power exchange should be limited. But if it is required, a reactive power supply should be given to the grid to maintain the voltage profile, and if the excess reactive power is there, the wind farm or solar farm should be able to absorb also the reactive power to maintain the voltage profile. So this is expected. It means both of the way it is possible. But if you remember, the reactive power absorption for a synchronous based machine, wind turbines are possible. The machines are able to absorb the reactive power, even they are able to generate the reactive power. But what about the WFED induction generator system? It is not possible for the DFIG to generate a reactive power. They are just absorbing the reactive power as the induction machine is there. But by utilizing the rotor side power tonic converter, it is also possible to generate the reactive power as well as to absorb the reactive power. So overall WFED induction generator with power electronic equipment, it is possible to have a function of generation as well as absorption of the reactive power, which we'll be going to discuss something more. Now see this curve. This curve is from a German grid code, which is expecting that how much reactive power should be provided to the grid when it is required. So this curve is for a voltage sag condition, that when a voltage is reduced, let left hand side figure, that voltage is reduced by let a 50% at a point of common coupling, then amount of reactive power required by the wind farm or solar farm is around 100% of the 1 per unit. It means as similar of the rating of a wind farm. So this is a very strict, very severe grid connection requirement, and that need to be followed by the renewable energy, especially wind in a case of German grid code. We do not have so very strict requirement, but it is broadly, it is provided that a range between 0.9 leading to 0.9 lagging should be possible for a technology to operate, whether SPV or wind turbine, based on the requirements. So this range is prescribed for in an Indian electricity grid code, 0.9 lagging to 0.9 leading. So every technology should be able to operate in this range as per the requirement of the grid. So this is what is expected from the Indian electricity grid code, 0.9 leading to 0.9 lagging. Now the next requirement is that a capability curve of the induction machine or any technology, renewable energy, should also be provided for to the transmission system operator, TSO. So, but we are aware of that no such capability curve was existing couple of years ago for a induction machine. But as I mentioned, that DFIG is able to generate a reactive power, absorb the reactive power by utilizing the power tonic converter. So that's why some of the researchers came up with a curve known as capability curve for the DFIG. Earlier, this type of curve was only available for the synchronous machine, but now it is available for the DFIG based induction machine based systems also, and these curves are required by the transmission system operator to understand that how much limit is available with each wind farm for further provision of the reactive and active power. So this is very important curves for understanding the current situation and the future requirements. Now the bigger fault right through capability which we are able to see is with the DFIG, and let's see how we will be able to meet. The basic meaning of fault right through capability is in two senses. The first sense is that the wind turbines should be able to, you can say, defend a fault for their safeguard, as well as they will be able to work during this fault and will be remain connected to the grid, so that they will be able to provide the active or reactive power to the grid. So this is what the overall broad sense of the fault means, making sure that the system is stable during the fault, as well as their individual wind farm, they are also safeguard during the fault. So both of the right through capabilities expected from the during the fault condition. Earlier, a simple disconnections were there, but now it is not expected. Let's understand this fault right through capability by using this curve. This curve is giving us a characteristics between the voltage left hand side y-axis and time in millisecond in the x-axis. What it is saying, that during a red curve and above, no disconnection is allowed, no tripping is allowed. What is the meaning of this? That during 0 to 150 millisecond, if the voltage level is 0 at a point of common coupling, still the generator of the wind should remain connected to the grid and should provide the you can say active and reactive power to the grid. So this is what a very severe fault right through capability. A possible short-term interruption is there during this time, otherwise it should remain connected. But as the time is going beyond 150 milliseconds, disconnection is allowed, but in a phase-wise manner. So this is what a grid connection requirement for a fault right through capability is required. So this is very severe German grid code. But in Indian grid code, we are able to see such curves are once again there, but we are not going even up to 0% of the voltage. It is, we are going let up to 15% of the grid voltage is there. Then up to that point, wind energy conversion system should remain connected to the grid, and later on, if it is going beyond 15% also, lower than that, and then it's possible disconnection is allowed. So Indian grid code is not as severe as the German grid code, and is giving a better flexibility for the wind energy conversion system or solar farm to work. And this time limit is also based on that what voltage level this fault has happened. So this is where the wind farm is connected. So it is different for different voltage level, and these timings are different. So this is how our Indian electricity grid code is working. Then there is a over voltage protection scheme is also given in Indian electricity grid code, which is saying that if it is a voltage level is going above, you can say 30% of the nominal voltage, then a instantaneous trip can be there. But if it is going up to 1.10 voltage level of the specified voltage, then a continuous operation is expected. So this is how the high voltage right through HVRT is also prescribed. Fine. So then let me just come to the power quality. The next grid code is expecting that a power quality standard as per the IEC 61400021 should be followed to inject the power quality or the maintaining the power quality at the point of common coupling is expected from the wind turbines. So in a broader sense, whatever the grid connection requirements we have discussed, it is expected that the wind farm or solar farm should be able to meet such grid connection requirement at point of common coupling by having technological enhancement in themselves. But if they are not able to meet such changes, such grid codes, then it is expected that they will be able to utilize some add-on equipment to either provide renewable energy in addition to renewable energy to maintain the grid codes. These add-on equipment could be a simple energy storage if a frequency stability or frequency regulation need to be maintained, or it could be static compensator SVC to maintain the reactive power. So this is how the add-on equipment will also be able to make this wind farm or solar farm as a grid compliant. So this is what a possible. Now, if you are having any query till now, then please let me know. If is there any query or question, then please let me know.
Sir, can you explain once again the Indian code for that fault right norm?
Indian fault right through. So this is what an Indian fault right through is there. So what I'm saying, in this case, you just see the left hand side figure. So the solid line is saying that if the voltage level is going beyond this solid black line, if it is lower than the voltage, then the wind farm can be disconnected from the grid. Fine. But if the voltage level is up to VF, the wind farm should not be getting disconnected, must not trip. They should remain connected to the grid and should supply. So this is timing is up to let 0 to t second. So 0 t second is what? It is 100 millisecond for 800 and 400 kV lines if the wind farms are connected to this voltage level, and 160 millisecond for 220 and 132 kV line. So this is what it is specified. So then it is saying that if the fault level is persisting, then the system can be disconnected. So, but during this curve must not trip during that region. The characteristics is such that the system should not be getting disconnected. So this is what I am saying. But slowly, when the new Indian Electricity Grid Code came, they have specified the right hand side figure, which is saying that if the voltage level is up to 15%, there should not be any disconnection up to 300 millisecond, and beyond that it should be disconnected. Is this fine?
Right, sir. Thank you.
Okay. Any other query? Any other query? So now quickly see the doubly-fed induction generator, how it will be able to meet the grid connection requirement. So just see that there is a DFIG, stator is there, right hand side it is a transformer and it's connected to the grid, and the rotor side there are two power tonic converters there known as rotor side converter and light side converter. Now, whenever there is a fault is there, a high amount of current is going to flow from this rotor circuit. So this DFIG in this chopper is going to activate it. What is the role of this chopper? The role of the chopper is that it is going to dissipate extra amount of energy in this rotor circuit so that it will be able to control the energy flowing in this, so that they will be able to safeguard the power tonic component. So this is how chopper is working. In chopper, a set of resistances are there. So this is how some of the researchers or literature are saying that the operation of this chopper is sufficient enough to take care of a very severe fault. So this is what they are claiming. But sometimes if let a chopper is not able to dissipate this amount of energy, then a crowbar is going to work. What is this crowbar? Crowbar is a non-linear, or let a set of resistances which is controlled non-linear by using a power tonic converter. What will happen when a chopper is not able to dissipate certain amount of energy? It will give a signal to the chopper. As soon as it will give a signal to the crowbar. As soon as the crowbar is going to come into the operation, it will close the rotor circuit of a doubly-fed induction generator by a resistance, and this resistance is able to dissipate the extra amount of energy. So now you are able to see when a crowbar is in operational, the DFIG becomes a simple wound rotor induction generator with a rotor is short circuited by this resistances. So during that operation, the power tonic components RSC and LSC are now out of this circuit, and that's why this is generally known as short-term interruption is possible as per the German grid code. If you remember, this is what is known as short-term interruption. This is how a severe faults can be right through. During the operation of this crowbar, the stator is connected to the grid and it is feeding the active power. But what about the reactive power? The reactive power in this case can be fed to the grid by using this line side converter. This line side converter can act as a static compensator, and it will be able to generate a reactive power and can feed into the grid by using this DC link capacitor. During normal time, the reactive power is being pushed by this rotor side converter into the rotor of a DFIG, which is then able to utilize its porous magnetization of the air gap and the other windings by using this DC link. So the reactive power requirement of this DFIG can be met by the rotor side converter. We are also able to see that by utilizing this rotor side converter, if a extra amount of renewable energy, extra amount of reactive power, reactive energy is injected into the air gap, that will be able to translate from this air gap to the stator circuit and then finally to the grid. So this is how rotor side converter can be controlled, can be utilized to feed the reactive power requirement of the DFIG as well as the reactive power requirement from the grid. So this is how a overall DFIG system will be able to operate to meet the fault condition as well as to meet the active and reactive power conditions. Fine. Then some of the researchers have suggested that why not to have a extra series grid side converter which is connected into the series, because some of the small signal stability studies have identified that there are poorly damped poles are there in the DFIG stator flux, and due to that there are severe oscillations are there in the quantities during the abnormal condition like faults and voltage sag. So this series compensation can also be provided. So this is one of the suggestive way of improving the configuration of the DFIG. So we have done some study on, I will skip some of the control structure here. I will just show you the results that for a very small wind farm for a 120 kV system where 25 kilometer of distribution feeder is there, that there you are able to see that there is a voltage sag of 50% and then some oscillations are there in the current and as well as the active and reactive power and the torque. But when a this series grid side converter is being used, these oscillations are being damped out, the relations are being are more you can say simple and without oscillation. So this is what can be also be achieved. So this is how we are able to see that DFIG is able to work to provide the reactive power, able to work active participation in the frequency control. They will be able to have a fault right through capability by different controller. So this with this I would like to stop here, and if there are any queries there, whatever we have discussed till now, let's have some more interaction in that. Please feel free to raise the questions now.